Can everyone see my screen?
Yes. Yes, I can.
Okay. So I'm David from Google, and today I'm going to talk about my device assignment proposal, which I think I linked in the meeting notes. But I want to give kind of an overview so everyone can understand the rationale behind it, and hopefully I can get some feedback on the use cases as well as the overall design. So first I want to talk about the 3 motivations I have for this. And the first one is the reason that I'm proposing this in the first place, which is supporting device monitoring. So currently, there isn't a way. So imagine for a second that we have the kubelet and it's running a number of devices on the node, and you want to monitor those devices with a daemon set that's specific to your device. The problem today is that there isn't a way for such a monitoring daemon set to discover the relationship between devices and containers. So you can monitor GPUs on the node, but there isn't a good way for you to figure out that container A in that pod is actually consuming device food. And so that's one of the things I'd like to solve with this. The second is that supporting network devices currently has a coordination problem. And that's because the advertisement of devices needs to be done by the device plugin, because that's the plugin, that's the place where you can advertise devices. However, network devices need to be set up in the pod's network namespace, and that portion is done by CNI, the container network interface. So right now there's a coordination problem because we have designed the device plugin interface to deal with advertising devices and plumbing devices through that are represented as mounts. However, we still need, at least for this network setup, we need some coordination. And the third I'm calling device scheduling, but essentially what I mean by that is that this proposal adds some flexibility to how we are able to who is able to assign devices. Currently, because the idea of device assignment is internal to the kubelet, obviously then only the kubelet has the ability to assign devices. And this proposal opens the door for other components, namely, say, a custom scheduler, to assign devices in the future to meet some of the more advanced use cases that we've heard of. But that's not necessarily as concrete of a use case as the first two, and I'm going to focus today mostly on the first 2 use cases. Are there any questions about those? Okay, I'll keep going. So what exactly am I proposing? I'm proposing adding a field to the container spec, which is a map of the resource name to device IDs. And so, for example, for NVIDIA GPUs, you would have the NVIDIA resource name, and then it would map to the string device IDs that are assigned to that container. And I'll go into how this can be populated later, but for the moment assume that the kubelet is able to populate these devices before it runs the pod, so that what we end up with is a scheduling decision made by the kubelet prior to the pods running that is observable by other Kubernetes components and that is permanent. So for device monitoring, the way that this proposal solves that is that imagine for a second we have one pod that's consuming 2 GPUs, and you are also running a monitoring daemon set. The monitoring daemon set needs to do 2 things. It needs to, 1, discover which GPUs are actually in use so that it knows to collect and expose metrics for them. And then it also needs to know the container and pod and namespace information about the container that's actually using it. And so in this case, the way that the monitoring daemon set would do this is by querying the kubelet's pods endpoint to discover the state of the world, as it were, in terms of which devices are being used, and can then start monitoring and producing metrics and attaching metadata for the GPUs that are currently in use by containers. Okay, and this is supporting network devices is a little bit more complicated, but I'll start with the device plugin in this picture, which all it's doing is monitoring the health and status of network devices on the node and exposing that through the device plugin so that those things can be assigned. And then the CNI plugin, and actually you would have to use what are called CNI meta plugins, which is sort of a plugin to the CNI plugin to, one, understand, it has to be aware of your devices. So you would have a plugin to the CNI plugin which, for example, understands a certain type of FPGA or something. And then when CNI add is called, and the CNI plugin performs the setup of the network namespace, this CNI plugin simply has to perform the plumbing for these two network devices to this pod, assuming, and it understands that because it queries the pod's endpoint, and thus is able to establish that device A needs to be plumbed to pod foo. Should I go over that again, or did people understand sort of? It isn't trying to solve everything about network devices. We've encountered a number of other challenges that we have with network devices, such as device programming. But one thing this does solve is it solves the coordination problem between these two plugin interfaces that we have. And it does that by exposing a public relationship between devices and containers that these two different plugins can act on. Okay. Are there any questions about either of those?
I guess just for context, there's a POC where this sort of interaction is happening, and I think they're just using annotations right now. It's round tripping to the API server. So this would be a big improvement.
Yeah, this is actually very similar. I think in today's world, they could actually still use the pods endpoint because you can get annotations that way. But yeah, this would be very similar, but more of a well-established, supported way to do this.
Yeah, and if you're talking about the POC implemented by Red Hat folks and I think also some sort of Flare folks, I think they are also getting the association information from device plugin checkpoint files, and that is currently not the long-term solution we want to go forward.
Yes. Okay, and then lastly, I just want to dive a little bit deeper into how device assignment actually works, just to give people a picture of how we would implement this and how it could possibly be used as an extension point in the future. So if the kubelet is performing device assignment, which is what we expect the vast majority to be the majority case, the kubelet receives the pod just as it does today without this field assigned. The kubelet then decides which devices it's going to assign to each container and records that in the pod spec and writes that back to the API server. And only after that's written then does the kubelet actually run the pod and expose the updated pod spec on the pod's endpoint. And then if you're running a custom scheduler, for example, then you actually need to assign both the node and the devices at the same time, as it were. And then the kubelet receives the pod and runs it. And the reason why you couldn't, for example, have one thing scheduling devices and another thing assigning nodes is because you can't assign devices until you know what node it's on. But at the same time, if you assign a node before you assign the devices, then the kubelet is just going to run it first. And then there's a race there. So you would actually have to have a custom scheduler do both in order for this to work.
I think kubelet will also do some basic sanity checking to make sure like the devices claimed by a pod are
Yes,
not
right. The kubelet would reject a pod if you just put foo and bar. Devices that don't exist are already used by another container running on the node.
So can I ask a question? So how does the kubelet know there's already device assigned to this pod as it's supposed to be before it says that okay, so there's already a node assigned to this pod?
Sorry, say that one more time.
So how does the kubelet know there is already a device assigned to this pod as it's supposed to be? Because
So the kubelet only ever fills in devices that are not already assigned. And this is actually useful because pods undergo admission, for example, when the kubelet restarts. So when the kubelet restarts, it'll restart and see that it's running all of these, like this set of pods, and the devices are already assigned, so it won't redo device assignment in that case. So
I guess Yang's question is how does a kubelet know whether a particular resource is owned by itself? It's a node level resource or it's some like a class level resource.
Right.
So currently in device manager, we track what resources a kubelet node, and basically we catch that information and we also checkpoint that information.
Okay.
But using checkpoint does have certain limitation. And a possible extension to this is we could add some owner field in that structure to indicate whether it's a node level resource or it's a class level resource.
Right.
But I think that perhaps should be kept isolated from this discussion at the moment, since right now we still use the checkpoint data as the source of the truth.
Okay, yeah.
And so from a container resource standpoint, this is still using the existing device plugins that are just counted resources. And then this would just basically say which specific resources were assigned after the fact.
Yes. So I guess if I go back to when the kubelet performs assignment, before the kubelet finishes admission, so between number 2 here is actually part of kubelet admission, where the kubelet will first receive the pod, then it will decide, okay, I'm going to give it this set of devices, and after that it has to perform an allocate call in order for the pod to finish admission, and only at that point does the kubelet know A, that the set of devices is valid, and B, that it knows how to actually perform, to plumb, it now has the information from the device plugin required to plumb these devices into the container when the container starts. And only at that point can it run the pod. Does that make sense?
Yeah. Yeah, I'm just still trying to map that back to one of the use cases you had at the beginning, which was asking for a particular NUMA topology. And I don't see how we can model that, but I guess maybe that's a tangential topic. So.
Yeah, so one example you could think of where a custom scheduler might be useful is if you wanted a specific NUMA topology. And in that case, you could choose a specific set of devices that meets your criteria and perform scheduling with your custom scheduler. I think there are definitely plans within the resource management working group to make the kubelet do things more intelligently at the node level. But there is also, it's not always possible to make a perfect decision from the node standpoint, because some devices may already be consumed, and those may not necessarily be in the formation that you're looking for them in. And so if you require specific properties about, say, the topology of your devices, for example, that maybe they're linked together if they're GPUs or some other things, then you're not okay necessarily with getting devices that are spread out on NUMA nodes or other things like that. And using a custom scheduler allows you to ensure from a cluster standpoint that you get what you need.
Yeah, I feel like for topology-aware scheduling, we are still at very early stage that we don't know how to represent topology across different CPUs or like devices, and how we can do this very advanced topology-aware scheduling. So I think right now it's not the main focus, but as David mentioned, it enables some experiments done by the community on this space. But I think it's still quite early to know which model is the desired model.
Mm-hmm.
Are there any more questions?
So are there anything network device plugin folks there? I think we do want to get some feedback to see whether this proposed model can help solve your or like unblock your use case.
Hi, this is Vikas. I think from since there are seems no folks from the network device side, so I'm taking this privilege and to represent them. So I think this proposal is really helpful in unblocking network device plugins. So right now POCs are being done where checkpointing file is read to know the mapping, and then plugin annotates the pod so that CNI can read that annotation later on to do the coordination. So this is really unblocking the network device plugins.
David, is this part of the spec or is it part of the status?
This is part of the spec.
So are you then like going to add like a new verb to the API to update this field?
Say that again?
So today, it's not all fields in the spec are updatable. There's just a few fields that can be updated. And specifically for the node name, for example, there's a special verb which lets you, a custom verb that lets you update the node name in the pod spec. So if you're making this part of the spec, then there needs to be another special verb that lets you update it. And then the semantics of that verb have to be defined.
Okay. Yeah, thank you for informing me.
I guess we need to evaluate how much work is involved on that. Yeah.
Because if you make it part of the status, it's much more straightforward, which should in theory like satisfy the monitoring use case. But if you're making it part of the spec, then probably we'll have to like think a little bit more, because for network devices, we might be having pod level devices in addition to container level devices. Because I don't see, like, it doesn't make sense for them to be container level, at least as of today.
Yeah.
And so we have to like evaluate what all fields can get updated by that verb. And so it might get a little bit more complicated.
Yep, I agree. I think that the representation of network devices as pod level is useful in and of itself and probably a separate discussion. I assume that if we decided to, for example, request these devices at the pod level, that then we would need to also have a similar field essentially listing the pod level devices that are assigned. But I think we can hopefully make those changes at the same time. And I think we can think of that somewhat tangential to this.
It seems orthogonal, and also, like as you mentioned, that means we need to support pod level resource request first. Seems.
Well, I think those should all be done as one. Yeah, but yeah, I agree.
Okay.
Yeah, the other thing is like, are you going to qualify, or actually, let me take that back. How are you going to qualify a device to a specific device plugin? Because device is just a logical string, right? Like you could associate that to anything on the node or
Yep.
something that are not even on the node.
Yep.
How is it going to be uniquely qualified?
Do you mean that, what do you mean by that? Do you mean that how do I ensure that device A is recognized by the resource it claims to be, or by the plugin that claims to own it?
I was referring to the plugin specifically.
Oh, like, so you're saying when allocate is called on a device ID, how do I know, how does the plugin know that it's a real device, or?
No, so let's say you have device plugins A, B, and C.
Mhm.
All of them exposes devices foo with the same name foo.
Yep.
And if a device foo gets assigned to a pod, how do you know that foo belongs to plugin A or B or C?
So these are all based on the resource name, or if I go back to the change, it's a map from resource name to devices. And so you could assign a device with the same name, but belonging to a different resource to the same pod. So I could get device number 1 from a whole bunch of different resources, each which is known by a different plugin.
Okay. On that note, just a nitpick, like I would prefer having a list instead of a map because we have a whole bunch of issues with maps.
Yeah, I guess we could, I remember that actually. So actually this would be a list of it would be a list of a struct containing the resource name as well as a list of device IDs. You're right, I forgot that maps are bad in API objects.
And maybe owner as well, whether it's a node resource or cluster level resource in future.
These are.
Yeah, I think also make it a structure may leave some room for future extension.
Could you share a little bit what's a particular problem when you use map, list of map?
Oh, I think you can look for API guidelines. They're just, I forget whether it's merging maps or I don't remember specifically, but I believe if you look for Kubernetes API guidelines, it explains why we shouldn't use maps. Yeah, Verb can probably tell us if you think about that.
Goes through most of the API.
For now.
Okay, thank you.
And can we also like add this as an alpha field to start with? Because in the whole device plugin thing is like really new. So
Yes.
I assume as people try this out and they get some more experience, there might be like new ideas that come up, which we might want to look at.
Yep, I think that's a great idea, Vish.
Okay, one more question. Who's going to implement this?
So my plan moving forward is
Just an ask KEP first.
right. So first, I think I should write this up as a KEP, and we should come up with a number of very concrete use cases. My hope is that I can enlist the help of some of the folks that are building network or building the POCs for network device plugins to implement a POC using this model and demonstrate that it works. And I also hope that I can enlist the help of some of the NVIDIA folks to do a POC for an NVIDIA monitoring daemon set, just to demonstrate that that works. And then if we have consensus on the KEP, I will probably, I guess then the next part is to have this undergo API review, which I'm sure will be loads of fun. And then after that, I suppose we start building it. I haven't decided if we should do a feature branch or not, but I think that can be decided later.
Yes.
Yeah, perhaps if it involves quite some the implementation work, we can also have some plan and break down the work so that we can get some help from the community to implement the different pieces.
Yeah, I think the actual work for most of this is not huge, and if we can find a couple people from the community to help, I don't think that the implementation work is a problem. I think the API review sounds like it's going to be the hardest part of this process.
Actually, I think alpha field, does it also need to go through API review?
I suggest we should. Alpha is not mean you still want user, right? So and also you still want a path forward. It's not like that.
Mm-hmm.
So at least this is a really good feature, and both Stark and I kind of really looking forward to this feature. So let's start to have the cap and then share with the community and got the consensus there and move forward. So let's move to next topic. If there's no more question, maybe you can directly send the question to the David.
Yep,
and in the slide, please include the slides into the agenda. Okay, so next one actually is also very related to this topic. It is our new resource API. And Vikas and Jain, do you want to talk?
Vikas, do you want to talk?
I will come in between. You can start, Jan. That's fine.
Okay. So this is a continued discussion on the resource API proposal cap. We presented shortly last week. Since we have more time this time, I think we will go through in more details. I'm sorry we are not as prepared as David. We didn't create any slides, so I will just go through the cap, starting from the user story. So the
make size bigger if people cannot see that. Yeah, okay.
So some of the user stories we have heard from the community, especially from the resource management work group, include currently, one use case we want to enable is we want to allow people to manage non-primary resources more easily and consume them in consistent ways as they consume primary resources like CPU and memory today. I think we mentioned in the last meeting, those extended resources are like non-primary resources. They usually have very different performance and characteristics, even for the same type of resource, like CPU, but different types. For example, for GPU, we have K8, P100, V100. Their performance and prices are very different, and administrators often want to give different quota to those different types of GPUs. And currently, we don't have a way to allow people to assign different amount of quota to different GPU types. And if we look at other areas in like high performance NICs and also FPGA, they also have very similar requirements. For example, for FPGA, they can be programmed with different bit streams, or like they can have different functionalities, and we don't currently have a way to differentiate such different types of devices. And another use case is we also want to provide some flexibility to cluster operators that they can use a portable name or some name they can they choose to manage a group of resources. And for example, for different types of GPUs, as time goes and more GPU devices are introduced, more types of GPU devices are introduced, it's not flexible or like it's not very easy to manage all different types of GPUs, and cluster administrators actually want to group them in small categories, in smaller number of categories, and they can hack the underlying configuration details from their end users, which also helps more portability on the workload level. And we also want to allow more workload portability across different environments, whether it's on-prem or whether it's across different cloud providers. It's similar concept or similar motivation as a storage class, where we allow people to have the underlying configuration details that match the underlying hardware configuration, but the workload itself can just use the portable resource name to request that resource. And also we want to enable device vendors, empower them to export their resource and their advanced features on Kubernetes. And currently, we don't have a good way to allow people to export different properties of device, and also to make a scheduling decision based on those different properties. And also we don't have a way to allow people to discover the properties and use them if they do affect their workload performance a lot. And another use case is like we have seen some requirement to be able to request a group of devices. Like for example, we have seen people want to be able to say, I want a GPU and also a CPU on the same NUMA, and also maybe with some amount of memory together. And currently we don't have a way to express these scheduling requirements. So, and in summary, the high-level objectives of this work is to, so first we want to allow workload to request compute resources with the different properties in simple and standard ways. And currently, because we don't have a way to offer this, we already have seen some non-upstream solutions developed in the community by people, and we already have seen some documentation in the community in this space. And we also want to allow cluster operators to configure and manage different kinds of non-native compute resources in flexible and also portable ways. And we have seen like different devices, they already have seen some of the needs to export the very device-specific properties in Kubernetes, because they can very affect the performance on consuming those devices. And we want to empower vendors to export their resources on Kubernetes more easily. And also we want to provide a unified interface to interpret compute resources across various system components, like Kota, container resource stack. And also we have seen like for cluster autoscaler, they also want a consistent way to evaluate whether a node can satisfy a pod resource requirement in a consistent way as a scheduler evaluate this. And in the longer term, we want to support the node level resource as well as the cluster level resource. And currently, we don't have a good way to differentiate the cluster level resource versus node level resource. I think in the past couple of releases, we added some the workaround on kubelet and also in cluster autoscaler. Those solutions are not very ideal, and we already have seen some requests that we desire some longer-term solution. As part of this work, we also want to make sure we can provide an easy and seamless migration path for the pods that are already using the raw resource name, we hope to provide an easy migration path for them to adopt the resource class API. We also explicitly mentioned some of the non-goals with this work, and in particular, it's not a goal to modify the existing container stack resource requirement API. This is a question like commonly raised in the community because people usually draw the similarity between like a PVC versus the like a special resource requirement, the like metadata requirement. But the reason we didn't include this in the proposal, there are several reasons. So first reason is mostly for the scaling concern, because evaluating the property, it's basically a label matching and evaluate such label matching for every pod and for every node compute resource is very expensive. And the reason we want to introduce a resource class, one of the reasons we want to introduce a resource class is so that scheduler can catch the matching information from resource class to compute resource. And the catching update is done when there are new nodes are introduced or there are resource class modifications, which we expect to be much less infrequent than like evaluating every pod whether it fits every node resource requirement resource available. So that's one of the main reasons. And another reason is we feel allowing people to directly specify the metadata requirements in the container spec, although it provides some of the convenience, it could also hurt the workload portability in the longer term. And I think that's also part of the reason why storage class was introduced after PVC. And also another reason is resource quota control will be very hard because essentially the label matching allows multiple matching, and it's very hard for administrators to prevent some pods from consuming the resources that they don't have quota for if we allow people to directly specify the metadata matching constraints in the pod spec. And also, we consider this as something or subnode to the resource class API proposal that we can add later. So that's the main reasons we haven't taken this approach, even though like some people have asked this question, and we also have seen some downstream implementations about this taking this approach. And also, it's a non-goal to unify with the storage class, mostly because the storage class, they have different requirements. Like for example, usually a PV, the life cycle of PV is longer than a pod life cycle. And also the storage class, PV and PVC, I think they are designed with specific storage semantics in mind. So it's quite hard to unify the two. So at this level, we don't plan to unify the two. And also in the initial phase, we will not address resource overcommitment, fractional resource requirements, or native compute resource. Although our design does leave the room to support them in the future. And I think we have talk about the future extensions we may consider to support them. It's just not our focus in the initial design. I think we have mentioned the major components in the last meeting, and from last meeting we also updated the design doc to make sure it's up to date and reflect our current design. And basically we propose to introduce a resource class as an API object, and we want to start with the very basic spec. It's basically just specify the raw resource name. But the example here we use is like nvidia.com/GPU. This has been the raw resource name we use for GPU for currently. And as we can see, it doesn't. It's at very high level. It doesn't allow people to specify what types of GPUs or any like metadata, like the amount of GPU memory or like the cycles of the GPU. But the metadata requirements is the key field that we want to allow people to specify any metadata constraint. It can be either GPU type or like the zone or like GPU memory. And we have provided some examples for the resource class, and also in the pod, it basically just specify the resource class name. And we also provided example for high performance NIC. And later we discussed some of the fields we may consider to include later. Like for example, we can introduce a scope field to declare whether it's node level resource or it's cluster level resource. And we can provide some auto provisioning config that can help the resource auto provisioning. And we may also consider to add some resource request parameters. This is based on some of the feedbacks from the community. Like for example, for some of the high performance NIC use case, they want to pass some special resource request parameters to device plugin to help configure the device into a state for that particular resource requirement.
I think until we finish, you won't go through a whole, because this covers so many use cases, so many detail, and so many components. So can we pause a little bit here based on the earlier use cases and go and non-go, and can we ask any question? Yeah, sure. First, then we can continue.
Yeah. So I think we from the comments in the PR, a lot of questions were related to the use cases and also goals and non-goals. Yeah, so we would like to hear some of the feedbacks, from folks here. Like, do you think we have a good balance and on the goals and non-goals, and also the user stories part?
I think one question to Jiaying is the first use case, which is the cluster has a different type of GPU, which is a heterogeneous setup. So the question is this a common use case, or maybe it's easier for administrator to manage that, make sure they are using the same type of GPU in the same cluster?
It's actually a real use case that we have seen even in on GKE. So what we have seen, like for some of the large customers, they usually have a cluster with the different node pools, and the different node pools use different types of GPUs. And I think it's also true, it may be even more true on-prem, like people may have a cluster with different types of GPUs.
I think we need to ask the people management those on-prem. So Jeremy, I saw you here also, and maybe you can chime in here. Jeremy looks like he's off his desk.
Actually, we also saw some feedback from Henry from eBay. He managed like eBay clusters, and he mentioned like he had many different types of GPUs. And actually, he expressed the use case, like he also want to group different types of GPUs into different categories, like smaller number of categories, so that he doesn't need to like tell all the workload developers like, oh, I have a new GPU available. Please modify your power spec to use this new type of GPU. Does that address the question? Actually,
yeah, I think it's certainly it's very useful. I believe. My question is just whether this is a very common use case or this is kind of an advanced use case. That definitely is useful. I can see the value of that.
Mm-hmm.
So when we talk to, I apologize, Don, I'm having problems with the meeting. This is Jeremy. When we talk to customers about the concepts that Jen just laid out a few minutes ago, most of them see it as very logical and mostly a requirement for their particular environments. And without it, essentially assuming homogeneity is not an option for a good amount of environments, I would say. Some are more flexible than others, particularly when they look to like bring Kubernetes in to a greenfield environment, then there's more flexibility. But when you get a year or two down the line, you start seeing these use cases pop up. When you talk with folks from established industries, this is, almost 100% of their environments need something that allows for much more granular, whether it's topology awareness or hardware awareness. Is that what you were looking to hear?
Yes. Yeah.
So it depends on who you ask, but from my chair, it's a significant majority.
Okay. Because I know you have some real customer here.
Yeah, and the more these features get in, the more customers will come. I mean, it's like it's a reinforcing kind of feedback loop.
By the way, I also can share a little bit. I also talked to the user, and one of their company or the user, they want to start with this GPU capability. I think because they are early, so they are looking for make sure every cluster has same GPU type. So I agree. Maybe 1 or 2 years down the road, they definitely may got this situation and have to manage different type of GPU in the same cluster.
So GPU capability, you mean GPU quota or?
Just enable GPU in the Kubernetes cluster.
It's like being
generally device plugin and all those.
Yeah, I think currently that may be still doable, but if we think about like in the long term, when you want to introduce a new GPU type and you just need to create a new cluster, that doesn't seem to be quite feasible if we think like in this space, more of the extended resources will be introduced in the future. And it's definitely not feasible for FPGA at least.
Thanks.
Any other questions on the user story part? And also any questions on the non-Go part? Okay. So I will continue on the design.
We will only have five minutes. Roughly.
Yes, so I will go quickly.
Maybe you can address last time Bobby raised a concern on the. So
yes.
You can repeat that question.
Yeah, unfortunately, Bobby was not here.
I think Bobby's here.
Oh, Bobby's here? Oh, great.
So maybe we can address that one. That's the one we left
yes.
last time.
So I think we can go to the schedule extension. So Bobby, we updated the type to reflect the current PR design model. And basically the field we proposed to add in the container spec to encode the binding information from resource class to compute resource. We call it allocated resource list. And basically it, well, we also use map here, but we may want to change it to a structure anyway. But basically it maps from the resource class name to allocated resource list. And here allocated resource list is compute resource name plus count. So that means basically on the scheduler, we will cache the information, the matching information from resource class to compute resource. That means scheduler need to update its cached information when new nodes are added. But that basically just match the compute resource exported by the new node to all the existing resource class. And also it need to update the caching information when resource class is modified or added or deleted. So
that's fine, but the biggest problem, I guess, at least in the previous design, this is a new part. But in the previous design, I guess you were proposing to support union of some resources, basically union of some compute resources, and expose them as a new compute resource, if I'm not mistaken. An example was, for example, if your GPU is connected by an NVLink and exposing all of those GPUs as a single unit, and that was causing kind of like a complex resource accounting, because if one of those GPUs was being allocated, then we would need to remove one GPU from the pool of GPUs, as well as that whole unit, which was basically enclosing this GPU, right? Just one GPU. So basically, multiple resources should have been deducted in case of an allocation of one single GPU. That would cause a little bit of a complex accounting and maybe a little bit of performance hits, because we needed to check many different resource types. So that was the main concern. I'm not so sure if this new change addresses that problem, or maybe you have completely dropped that idea. What is the update on that?
So that is to support the group resource. It's not in the initial phase of the design, although I think we can handle that in a similar way. So basically, in a similar way as we support multiple matching. So basically, a computer resource can match multiple resource classes. And our proposal is like once scheduler says like a computer resource is assigned to satisfy a resource class request, it will increase the requested accounting information for all the matching resource class. So this allows us to support the multiple matching from computer resource to resource class, and also to avoid double counting problem. And I think we can handle group resource in a similar way.
So basically, basically what you were saying is that resource class to compute resource is a many-to-many relationship, right?
Mm-hmm. Yeah.
Okay.
I think what we
Many-to-many causes a little bit of an issue, in my opinion, because it becomes hard to create like maps from one side to the other. One-to-many we can handle. One-to-one, of course, is easy to handle. But many-to-many becomes a little harder to handle. What's your take on that? I mean, we probably need to have a lot of maps, especially if the number of computers is large. We have to have many maps in the scheduler's memory, and that worries me a bit.
Yeah, that's definitely a concern. So that's also the reason why we don't want to address group resource until like phase 3.
Because how we prevent people, like the basically current way, we basically couldn't prevent people to do the many-to-many. I think that, Bobby, I agree with you. I think that even before we discuss, we do have this concept. We think about many-to-many actually cause a lot of the management overhead, and actually it could potential could be error prone to this one. So
yes, I agree that this actually becomes a challenge for admins to manage. Well, that's
delay the manage the handle. The problem it is from current proposal. I think anyway we prevent to user to in the phase 1, phase 2 to using that model. We didn't handle.
We don't provide semantics to support the group resource at the moment. So we currently support the computer resource to resource class, like a one-to-many mapping from computer resource.
So we are going to validate, make sure this is only one-to-many mapping, and then if it's not, then we invalidate. Basically, that's what a lot of meeting or offline meeting, that's what we suggest. Are we going to make sure? So now how are you going to guarantee that?
So we support one-to-many mapping from computer resource to resource class. But I think Bobby's question is whether we want to support many-to-many mapping from computer resource to resource class. And that I think that's not our current focus, and we definitely need some performance data to make the decision whether we want to support that model or not in the future.
Okay, sounds good. As long as so we have thought carefully about this issue. I'm fine with going forward with like one-to-many at the moment. But if in the next phases we are considering many-to-many mappings, we need to basically revisit this.
Definitely. I think even for initial phase, we mentioned like we need to do some scaling, tests and collect some performance data and also publish some best practice. Okay.
Yeah. So one quick thing, I've already told you this, but for the information of other people in the room, one thing that I, for example, got informed of in last KubeCon is that people were asking me why scheduler is slow when they have like thousands of resources in a cluster, and I told them, oh, what thousands of resources? We don't have that many resource types in the world. How could you have like thousands of resource types? And they say that, for example, they create IP ranges and expose those IP ranges as extended resources. When you give people the ability to define new things, they could become creative in a way. And this is also having the same problem, in my opinion.
Yeah, definitely agree. And I think with the support of extended resource, we are already allow people to do that. And we hope through this work, we can at least give people some warning when they create a resource class, when they create too many resource classes, or when they create a resource class that can match too many compute resources. But yeah, definitely, I think that is something we need to take special attention. Yeah.
Sorry, we ran out of time. And okay, so we can continue. And maybe you can summarize what we discussed.
Okay, I will write a summary in the.
So looking forward to talk to you guys next week. And thanks if you have any topic and any proposal, and please put it into our agenda. And also move to the discussing to all the PR, like the CAP proposal made by the Vikas and Jain. Okay, thanks everyone.
Thank you.
Thanks.